In the modern business environment, organizations, including retail chains, logistics firms, banks, and hospitals, depend fundamentally on data. The full value of this data is realized only when it is systematically organized, structured, and linked to accurately represent operational processes. This underscores the importance of prioritizing data modeling from the outset. Workbench might look a bit technical in the beginning, but once you begin creating ER diagrams, you will start to realize that it is more like a canvas. Once you have the blank canvas, pause and think about how to convert a messy business process into a clean structural map and what are the core entities in this business. For each table, define a name that reflects real-world meaning. For example, instead of naming a table ACC, write accounts. If you cannot explain the business in 4 to 6 major components, you are not ready to model it. For example, imagine a simple online retail business that has customers, orders, and products. Next, inside each entity, list the attributes. For users, include ID, name, email, etc. Each attribute should answer a specific business purpose. If you cannot justify an attribute, do not add it yet. Work every table around a primary key. A strong primary key guarantees uniqueness. A primary key ensures that every record can be identified uniquely. Without it, two customers could appear identical, two invoices could be mistaken for one, and orders might become impossible to track. In a retail system, product ID is essential because 1 liter milk and 500 milliliters milk must never be confused. Similarly, in a hospital system, patient ID ensures that two people named alike do not overlap in medical history. While primary keys identify individual records, foreign keys establish relationships between tables. A foreign key is an attribute in one table that refers to the primary key of another table. When a customer places an order, foreign key ensures that the order is not orphaned and connects dependent records such as user details or contact details. This connection mirrors real-world dependencies. A foreign key enforces discipline in the data so that there is no order without a valid customer or user. The combination of primary and foreign keys forms the backbone of relational modeling. In essence, primary keys guarantee identity, while foreign keys guarantee connection. Moreover, each attribute must store the correct type of data, numbers, text, dates, Boolean values, or decimals. Data types enforce discipline and prevent incorrect, messy, or inconsistent entries. For example, a price must be numeric or decimal, not text. A customer name must be text, not a number. A not-null rule ensures that an attribute must contain a value. This is crucial when certain information is mandatory for the business process. Default values ensure that when no value is manually entered, the system automatically fills a standard one. This is useful for attributes that follow predictable patterns. Primary keys ensure identity. Data types ensure correctness. Not-null rules ensure completeness. Default values ensure consistency. These constraints protect the business from data quality issues such as duplicates, missing information, invalid entries, and misinterpretations. When these rules come together, the data model becomes trustworthy and robust. Creating an ER diagram is not just a technical exercise, it is a thinking exercise. It helps to dissect real-world businesses into clean, modular, and connected data structures. The more realistic the model, the more meaningful the future analysis will be. When a new data model is created in an ER diagram, each attribute added to an entity is not merely a field, it is a decision about how the organization wants to store, protect, and use its information. Rules such as primary keys, data types, default values, and not-null constraints give structure to the data and ensure that the final system behaves predictably, accurately, and efficiently. Now that the entities and their attributes have been defined, the next step is to use Workbench's relationship tool to define the relationship between entities. Relationships define how entities interact with each other in a data model. Choosing the correct relationship type ensures that the database behaves in line with real-world operations and supports reliable analytics. A one-to-one relationship exists when a single record in one table corresponds to exactly one record in another table. A one-to-many relationship is the most common relationship type in relational databases. One record in the parent table can be linked to multiple records in the child table. In a non-identifying relationship, the child entity has its own independent primary key. The foreign key exists, but it is not part of the child's primary key. An identifying relationship exists when the child entity cannot exist independently of the parent entity. In this case, the child's primary key includes the parent's primary key. The last tool is using existing columns. When you connect orders to users, Workbench automatically suggests a foreign key. Accept it or refine it. Whenever you face confusion about which table should hold the foreign key, ask yourself, which entity depends on the other? The dependent entity is the one that holds the foreign key. In a well-designed business database, information is deliberately stored across multiple relational tables rather than in a single massive file. When the relationships of entities are defined, this is the moment when the data model becomes alive. They force clarity about ownership, dependency, and data flow.